I have a quick question, I guess you could say. The project that you showed, the Dart project, that was the 3D printed kind of columns where you were doing different typology optimizations there. Those were 3D printed plastic molds, it looked like, and you were using two different types of plastic. How were those like cast, and what was the reasoning behind that?
Yeah, the very last projects on the column that I passed very quickly was plastic formwork printing, and one of them was exactly correlating to the concrete cast. The other one was a multi-material formwork. It was made of PVA and PLA. PVA is water dissolvable, meaning that you don't have to remove it after, you just add water and it just dissolves. So where you have complex geometry, where you can't put your hand in and open up the formwork, you could basically add water and let the formwork dissolve. It's really it opens opportunity for building stuff where you have no access, and then cast, and then the formwork would dissolve because of the water. In this case, we didn't even add water. The formwork dissolved using the concrete water itself.
That was going to be my follow-up, was because there's so much water content. So the molds kind of, if you can imagine that on a larger scale, I think that'd be very interesting, where that might be one of the first ways you could do cast concrete construction, where the mold dissolves itself after it's completely finished.
Right.
All right. So now we'll get into some of these discussion questions so that we can learn some more about your ideas and how you're thinking about computation. So what is computational design to you?
So perhaps I would go back one step. What's computer first? I mean, to me, computer is a collaborator, right? In one way. So I see it as a tool where there was a time that you would just use it to do something that you wanted, but then today with computation, which is a process, it's not really the tool, the process that you can implement or develop through the medium of computer. You can think together with computer, because through computation and using the medium computer, because you can compute material also, you can explore computation materially, physical computation, but the digital computation would really, it's in some way disconnected from the physical world, and it can provide you with surprises. It can help you explore areas and calculate for you very fast. It uses the computation power to calculate quite fast, or calculate things you might probably not be able to calculate at all yourself. But also beside that ability, it gives access, or like in design, it's been introducing a lot of unexpected result, depending what technique you use, such as subdivision, where it's a surprise, and that element of surprise also helps you to rethink your design, to inform your design in some way. So it's really a power to calculate and generate, and in architecture also integrate data. Yeah.
Awesome. So you have a background in both architecture and engineering. Would you describe that as that expertise is kind of needed for maybe like a student or someone who's trying to become more of an expert in additive manufacturing? Do you think that's kind of needed, or would you recommend like a different route to go?
I don't think it's needed. It's not necessity. That just happened that I had both of this background. There are many of my students that are just architect and are taking additive manufacturing in their courses, and they're quite successful. So also some engineers who've not had any experience with architecture that are using additive manufacturing are doing really cutting edge project with. So I don't think you would need in this era, especially where you can learn from internet. I think a lot of people can work with additive manufacturing, even with very basic knowledge that they have, not necessarily within any field.
Awesome. Do you think, what do you think the current barriers are of kind of digital fabrication moving into traditional construction right now?
This is a difficult question to answer in US because I'm new here. I don't know really in the context of United States. I've seen in the context of Switzerland that companies are willing to learn and be with you. But however, I mean, when you say what are the barriers, it's probably more skills, like the existing contractors or the companies out there who are constructing are not having the skills compatible to deal with these technologies. New startups are still small, and bigger companies needs to educate their employees. So I would say the biggest barrier probably is more transfer of knowledge to the industry.
Do you think that with your experience with the dFAB house, we've had different presenters talking about the idea of using a BIM model, and that's kind of how the contractors work off of, but then contractors are known for kind of using these 2D drawings. What was your experience with that? Was it they wanted to have something that was more of the same that they know, that they can kind of go off of, or were they so eager to learn these new ideas that they were opening to new methods of doing what they've done in the past?
Yeah, I mean, in the case of Smart Slab, I think we were also very lucky. Our contractors were very flexible in terms of they were still using their own tools. It was us who were taking their outcomes and reintegrated to this mega or ecology of models that we had. So they still use their tools and their ways of analyzing stuff. For example, even post-tensioning, it's been done really in a very traditional way. They send us a lot of drawings for how these have to be laid out. And it was us who translated that and tried to integrate it into our design. So that was even in that case, they weren't really necessarily adopting. We didn't use any of their software, but we could communicate, we could convert our data very easily to what they needed. So that was easy to do. I don't remember what was the second question you asked me.
It's just more of if they're like, if they were willing to accept kind of the different, I guess, over the traditional methods of delivery, but I think you kind of answered that. Were there some, so I've watched so many of the dFAB videos, and even today I've learned new things. Like I didn't know the Smart Slab was insulated and how you guys did the soundproofing. What were some of the maybe learning moments or challenges of that project that aren't really shown in the videos? Like, was there anything that you kind of learned from that whole process that hasn't like made it into any of that?
Yeah. So a Smart Slab initially was going to be a stay in place formwork, like sand, and then concrete cast in it. Not that it was removed, but then we learned, for example, in the process that, well, it's not approved by the city. It's maybe we have no proper data for fire resistance. We don't know if the fire comes, it will collapse on people's heads. So it's out of the game. You cannot have the sand, and it's removed. So it was a lot of things that's why the first slab you saw, the topology optimization one had stay in place sand. It was part of this exploration. But as we went on, we learned a lot of things, yet we haven't even, not that it's not just approved. That's one problem in general, but another thing, we haven't had enough tests to say, oh, it would actually resist all this problem. We had to do a lot of new tests to pass through the permit of this building. But I must say that this project was also very flexible. I can't imagine doing that in Canada or Toronto, where things are quite conservative in terms of, and the code is very restrict. Yeah, and there were other things. We wanted to have a slab with no rip in the other direction, and this didn't happen. It was just not possible. We hoped to never integrate rebar at a time and just have high performance fiber reinforced concrete. And we imagined this would be the future, but it wasn't possible today to just not have rebar at all. And that changes the design. When you have to have rebar, you have to have this continuous element going through all the ribs. It constrains your design. But we certainly learned a lot. I mean, as I went through material yesterday to just drag some stuff to show you guys, which was more into the concept. And so I realized how much we've done, and we've never actually, we had to do a lot of tests, and then maybe 80% of it went to garbage and one succeed. And then it just kept being in everything, both in prototyping, in design procedure. There was many tests for the prototype itself, like actual physical prototype. And some of them just did not pass, either because of the time limitation, budget limitation, sometimes technological limitation, or let's say not technological. We didn't have enough tests to you know, I think none of us could really feel we can sleep the first days that this slab was right there. We thought, what if it falls on someone's head? But it was, at some point we were confident this works.
So that point you just made about, you know, the different constraints of cost and time, those are kind of one of the advantages of computational design and digital fabrication. Have you found it to be easy to compute, where it's let's say it's additive manufacturing and the final piece is just that, like the last project you showed, versus the ones that are being cast into? Is it, once it leaves like the digital kind of know you can predict, does it become more difficult to kind of figure out those?
To figure out the cost, you mean?
The cost and the time. So like versus, I guess it would be 3D printing the mold versus 3D printing the actual object. Now, like leaving the digitally fabricated portion, and to that portion where you have to put in those man hours, is that, would you say that's the most difficult portion to come up with the estimates, because it's so much unknown?
Yeah, good point. Very good questions you have there. Well, obviously, when you directly print and it's not in direct print, you have all the data there. You know exactly how much material you are using. You know exactly how long it's going to take. You can calculate that. I have the calculation for all the facade, a kilometer time-wise, and you can estimate everything right as you design. Well, in terms of indirect printing of the formwork, and so you still can estimate the price for everything. The volume of concrete is precise, right? In the design, the amount of formwork, CNC elements, and all that is calculatable. The labor part obviously is not calculatable. The trade part is not calculatable. They might take longer to do something. And yes, we couldn't say if this is going to be 2 days or 3 days when a spraying is finished, because we were not doing it with a robot that we could say it takes this amount of time for the robot to do one surface. It was a person doing it, and it had estimates of this is how long does it take me to do each segment. And it did go up and down. It wasn't like just that precise, but it was quite close to what was estimated, I must say.
Awesome. All right, so let's zoom out a little bit from just your projects and talk about 3D printing as a whole and as an industry. How do you think 3D printing will change architecture?
In a lot of ways. So I think, for one thing, it will change the way we'll design. And as I said it earlier, you might just no longer need 2D drawing at all to communicate. So that means you are operating only in 3D space. And if as soon as you are in a space where you design and then you print, and this is the direct connection. It's like really, I had this discussion with a colleague of mine in New York. He said, it really feels like a new animal. Like you can print the entire building if you want, like even concrete printing. And we've never really been there to understand what does it really mean. You are no longer, how do you design? What is the evaluation criteria for design here? Like when you don't have 2D drawings necessarily to look at, unless you're making a section of a design, but to talk about construction, assembly, and you are talking about different problems, you know, different level of problems. So it's going to change our design. For one thing, it's going to change the way we communicate with other trades, but it's also going to change our design tools, because 3D printing provides us with so much opportunity. And as I showed in detailing, in interior, you can do a lot of functionally graded parts. And we don't have right now any design tools out there that is robust, where architects in the scale that we work, not in the scale of nano scale and micro scale, we can design building envelope with functionally graded interior, inside or interior feature. So these are new tools that will come in years. When I said that we can design the interior of these, you don't expect architects to sit and design interior manually of all the walls, but it's an opportunity which this technology is giving us. And by that, we will eventually have design tools that would help us to control the acoustic density of insulation involved, density of whatever else to deal with something acoustic or thermal breach. So I think it's going to change a lot of our design tool, and even our communication tools, and especially with VR, the AR, XR, all these things could help us to move and shift toward a different area. This is really not about just 3D printing. As you all know, this XR and especially augmented reality, where you can, while you're working, you could simply have a projection of where you want the hole and you drill with your hand. So a computer can, or this system, these machines can help humans to operate their own easy work, because not everything is easy with robot either. Sometimes robot takes, for a simple task, it might take much more, it might be much more difficult for a robot to do it than human. So therefore, this human machine collaboration would take us, it's very important, and would allow us to use each of us in the best that we fit. We might not want to carry heavy stuff, robot can do it, but we might enjoy drilling something with our hand, and then use the augmented reality to project where the holes are and just drill real quick. Yeah.
So what things have you found humans are better at over the robots in some of your projects?
A lot of things. This is a difficult question. That's not fair. You know, I mean, it's a difficult question in the sense that some things are more difficult to program the robot to do. And this is really our technical limitation now, but then it will change. So I don't want to say it and it change in 10 years from now. But one thing, a robot is just a machine, and you program it at the end to do certain tasks. And if you don't program it and you use machine learning, still there's a set of algorithms that help this machine to learn a set of tasks and performance in a way. But I mean, when you say robot, you know, is robot with brain with computer, or a robot without computer? It's a robot with a program in there. And that, I think generally robots are great in doing heavy stuff. They're great in doing things that you don't want to stay overnight. We have left the facade printing there for nights. But to answer your questions, as a person, I've been so far very, we have some sort of consciousness. Let's say if there was a lot of meats and then one of them was bad, we would immediately smell, and you know, we have all the senses in place. And I'm not saying that robot can't have it, but you have to program a robot visually to detect a bad meat from a good meat. And if, let's say, your program was for the robot to stand there and place meats or just visually see it. If the color was just the same, robot wouldn't smell it. But if it was a human, we would have seen it's the same color, but the smell would have made us make different decisions. So we are quite, we have very integral senses, which helps us to quickly decide on a lot of things. And I think that takes a while to integrate into robotic in that synchronized way. I mean, that example that I gave, it's more probably philosophical, but I mean, you program a robot to do certain tasks. And even if it's machine learning, you say, learn how this, if there's not enough red, like you teach it how red is, and then it learns all the 10 reds. And then if something is not red, it detects. And if it's red, but it's not right below and you don't know it, but it smells really bad, because it's not already accommodated with another sense, and we didn't predict to accommodate it, then it wouldn't detect it. But human can have all those senses, or has all those senses, and would register that real quick.
I think that's a great comparison. One of the things with going to that kind of next level of providing those robots that intelligence, it's the same problem that self-driving is trying to solve, is how do you take a bitmap image and vectorize that environment and then give that intelligence to machine learning and then give that robot that. Once we have that, then the robots can build just like the human, right? So we have a few questions from the audience that I'll read off. So Leland asked, how expensive / feasible is it to include robotically manufactured feature wall on a real project? Most of us probably assume it is out of budget, or is it? Or should we challenge that notion?
Oh, is it plastic, or what was it, the material?
You didn't specify material, but does it, how does that change things? What if it's plastic? What if it's concrete?
Well, it makes a big difference, right? Well, for one thing, no, it's not more expensive. I mean, with both cases, I mean, if you have a robot at home, you buy concrete and you print, and the amount you can go to Home Depot and buy the pack and mix it yourself and pump it. It's just building that system once, and then print it, or have an access to a place that has the machine. So to me, this is not expensive. It's a matter of access, and robots aren't expensive. They've been there for a long time in every industry, and not just construction. It was missing somehow. It was slow, but I think everything with robotic and digital construction would be cheaper. As a matter of fact, you are using less material compared to if you would have cast, or if you would have molded a plastic. If you wanted to mold these forms that we've done in plastic, you had to first produce the mold in some format, then you had to vacuum form it, or you had to, if it was timber, or wood, you had to laminate it. You had to find other method to do it, and it would have double your material cost. It would double your machining cost and tooling cost. So I don't think it's at all more expensive. It's actually cheaper, and it's feasible to use it. There's a company which is 3D printing facade and selling it, and not plastic, but they are printing a special plastic and spraying, I think, foam or something inside and selling it as panel. It is, to me, the only thing you would need is the skill to do it, and then the startup budget to buy your first equipment. And that, to me, is not really expensive. This is not it's like saying I need a CNC machine, or you need a drill.
Yeah, so it's the tool is the fabrication element. It's kind of the upfront cost. So we have a question from Josh, who I was thinking about this as well when we talk about 3D printing. Maybe it's the customization versus the mass production, but Josh is asking, where do you see the future of material of alloys in computational design and manufacturing, leveraging different material properties and their architectonic relationships to one another?
Did he say alloy?
Yes. Material alloys in quotes.
There's a lot of alloy being printed right now, right? Like, I mean, it's already happening. I don't even know if it's a future. We have the bridge being printed. We have a lot of things being printed right now with alloy. So I think there's also areas that are not explored. So I've shown the cast version, but then another thing is that, let's go back, keeping this question in place, going back to your question, you know, some things may not be feasible to print one by one, because let's say if you are having 200 joints that are exactly the same, right? Not every one of them are different. If it would have been easier to cast all of them one instead. So I don't think it's you're not gonna lose casting. We're just gonna find out where each technology would fit best. Yeah, I mean, there's a lot of alloy printing is happening. So I can't say how the future would be. I mean, there's a lot of promises on larger scale metal printing, and there's a lot of work going in there. So the future is current, but probably the future I'm saying is like NASA, and so it's already exploring this, if that makes sense.
So you've touched on this a little bit on a few of the projects. How do you see additive manufacturing methods in relationship to sustainability strategies? So like, how do you see like that full process? I know you were talking about how plastic's recyclable, but maybe like also talk about like lifespan of these type of things and how 3D printing concrete versus casting concrete, like what's the recyclability of those?
So, I mean, I can say I haven't myself explored recyclability in terms of longs, you know, like really investigating it and know how long, for example, a 3D printed plastic can be out there in the sun and then you can recycle it, but it would be the same for maybe with a bit of difference for non-printed plastic. So I don't know the lifespan for this thing, and nor I know the lifespan for how long a concrete printed element would stand versus a cast one. This would be a question that probably somebody expert in that area could have answered. An engineer who studied durability could have said, because most of our concretes, also cast concrete, needs maintenance after certain years. There's cracking and you need to maintain them. Obviously, 3D printed concrete so far there's problem with shrinkage and there's problem with cracking and all of that. That's why it's still not yet there in the speed that we expect it to be in the industry. But there's new research also that allows us to overcome those challenges. The reason is not everywhere. It is not because it's expensive. It's because there are still technical challenges with concrete printing, from integration of rebar to because you have a huge surface area that is exposed to air, and then the water that concrete needs to set and cure, it's evaporated fast. But there are, again, all these, if you work with material scientists, which we do very closely, they've have all this new mix, and that's why I said new material innovation. Also, like there's new materials, new concrete mix. Yeah.
What have you found the limits of like the various materials and the various like printing, like FDM versus SLS? Like, have you found like right now you seem to be working with FDM and the 9-axis robots or whatever, but earlier you're working with SLS. Was that just based on the project type, the tools you had, and what are the limitations you've like seen with those different tools?
Yeah, so I mean, not material. Well, it's the technique. The FAF, the FFF printing would be more that you don't really have the support that you need. So the cantilever area, all of that would be the challenge. You have a limitation for how much you can cantilever without support. But again, there are research in place where it would allow you to even do extreme cantilever. We are developing ourselves a method which would allow you to conduct certain level of cantilever. Every of these 3D printing technology comes with their benefit and with their problems. So it's not the same. That's why based on each project, you decide which to go with.
All right, so we'll wrap it up with a few more questions. Where do you often find a design limitation comes from? Do you find it on the computational side or the fabrication side? During the design process, when you're thinking of something, is it usually after you figure out how much time it's going to take to print, or you have those limits with like the computation without, writing 100 lines of code for something or something?
I mean, I definitely don't see much limitation in computation at all. I think the computation is really enabler in a lot of ways, especially with the printing. And so there's definitely limitation with different fabrication technique. But my only limitation is time. Just don't have time. So I think there's more limitation most likely with fabrication than the computation, especially with 3D printing, right? Like you can almost print anything, design anything, and computation doesn't cost or doesn't have much constraint there. Oh yes, computation power. Computers hang and they kind of close at some point. So that's a limitation when it comes to computation. Not the design, not the procedure, not algorithm, not the code, but the power. You need sometimes you need mega computer to calculate a process because the files are too heavy, and so, or the process like of subdivision of billions of faces or mesh faces are taking too long. It takes a night or so.
So relative to the different functionality within a building and the different solutions that additive manufacturing could provide, do you think additive manufacturing is more beneficial as a whole building, or is it maybe portions of a building? And then what aspects of a building do you see better suited for additive manufacturing?
So I don't think additive manufacturing will go either way, like this or this. It would take both paths, and it's very suitable for both paths. It can suit pretty well for on-site construction as well as off-site construction. But obviously there are challenges for each. It would really depends to the material, and then this site, if it's a site that doesn't rain or wind every night. I was in an event where RAS, the company who is printing a lot, was showing their project in Dubai, if I'm not wrong, and another project they had in another location, and how just changing location and on-site printing would challenge them in order to make the project happen when you print on-site. So off-site printing in general is much more precise and easier to control the environment. But I don't think printing would go this way or the other way. I think it would go both ways, as we will not throw out our old techniques like casting, but we will actually work together with casting using our new technologies. All
right. So last question. I'm sure there's a lot of students here. So what advice would you give a student who wants to become more involved in computational design?
Come to Michigan. Well, I mean, come on. We've got a best, not only laboratory in North America, but we've got an ecology of people from different area of digital design and digital fabrication at Taubman. And I can, with confidence, say we are one of the best collection of people at Taubman. We've got the program Digital Material Technologies, which is a one-year program that the students can join for 1 year, and it's very interdisciplinary. We don't necessarily just accept architects. It's very interdisciplinary, and students can apply, especially if they have a good portfolio in terms of like or intent background. It's quite competitive, but that's a very good program from my point of view, because if you are not necessarily architect, or if you're an architect and you want to take this 1 year, you get this dense knowledge, and then you can go out and do what fits you best. We also have PhD programs. So I think taking these kind of programs that are not too long, but in a short time you are introduced to many technique and technologies, will be very beneficial if somebody is interested to expand in this area. I didn't mean to advertise Taubman. You just asked a question and I just said the truth.
So now I'm going to ask it another way so that the people who aren't there you can answer for them. How about someone who they're beyond their education years and they want to learn more about 3D printing and computational design? What advice could you give them to how to learn about it more? What should they think about? What experiences should they try to create?
I mean, for one thing, 3D printing is really cheap. So you can start with buying your own 3D printers. You can even do it yourself, buy super cheap one and make it yourself at home. Start small, but if you are in the architecture world and construction, you want to start touching it in a larger scale, because it does make a difference. Printing something in this scale and printing something in larger scale is a different, it's very different. Not every, I must say, not that they cannot be in future, not every technique and technology can be scalable so easily to architecture scale, as we also have to consider the weathering, the material as it scales up has to take the load, the structural load. And these are questions that we deal with in our field, which is not easy to explore when you're just in a small scale.
Right. No, they don't scale up proportionally. Well, Mania, thank you for your presentation, and thank you for, oh, do we have one more question? Let's see. How does architecture firms integrate digital fabrication into their workflows?
Good question. There are many ways. I've also worked in architecture firms before, and I do have my own. So one way is really start with workshop, really small workshops, invite people from different expertise, and have those workshops for the people in the team, because I think every office needs to grow. They can't just stay in a production mode if they want their employees to be on top of the field. So I've seen workshop works very well, from computation workshop to, collaborate with universities on even fabricating something, do something with a studio or research. You can collaborate with researchers as well on a research project. I think research-based project is the best way to learn, or let's say project-based is the best way to learn, because if I come and just teach a bunch of people, okay, this is how you do mesh, this is how you do this, but then they never implement it into a project, you forget it. And you best learn when you start struggling with it as part of a project, and you self-learn it in a way. And I think we have a lot of, we ourselves have a lot of experience of collaboration with offices, where we send our researchers and we do something together in collaboration. So yeah.
Yeah, and I think even particularly in Detroit, where we're all located, is there's a few companies now. There's startups that are doing 3D printing concrete. There's companies that are reselling these 9-axis robots for purposes who people want to use them like that. There's small scale digital fabrication companies who I'm sure all would be interested to connect with architecture firms and kind of show off what they're doing and start to make those collaborations happen.
Right.
All right, if there's no more questions, I think we want to thank Mania for coming out for the presentation and for the questions and answers. I want to thank everyone for joining the event today and filling out the poll and sending your questions. And with that, I think we can end the event. We'll see you guys in a few months.
Well, thank you for having me. Really, it was nice to have a presentation here. And feel free to contact me if anyone has a question. My email is on my website, in the Taubman website. So feel free to drop a question or anything you need. We are new to North America, but I'm sure we will be integrated. Yeah. Thank you.